Hi there, I'm Rayi, and I'll be sharing with you about sound and light waves. Surely you have heard the terms about sound and light waves and even have applied them in daily life, but maybe you don't realize it. So now let's get into it. Have you ever checked your appearance before heading out when you're getting ready in the morning? This is an everyday example of reflection waves that demonstrates how they actually play a crucial role in the world around us. Whether you're getting ready in the morning and check your appearance before heading out, you actually experience the practical application of reflection waves in your daily life. This reflection involves a change in direction of waves when they bounce off a barrier. This reflection also refers to when a wave strikes an object or surface and bounces off. Then the wave bounces back at a boundary. When light waves encounter a mirror, they undergo a process which is known as reflection. This reflection happens due to the interaction between the incident light waves and the smooth surface of the mirror. According to the law of reflection, the angle of incidence, which is the angle formed between the incident light ray and the perpendicular or the normal line to the mirror's surface, is equal to the angle of refraction, which is the angle formed between the reflected light ray and the normal line to the surface of the mirror. Instead of passing through the mirror, these light waves bounce off its surface due to the reflective layer on the back of the mirror. The reflected light waves then travel back towards our eyes, allowing us to see the image of ourselves or the objects in the mirror. When we're listening to music from a speaker, the sound we hear travels through the air as waves. These waves are like invisible vibrations moving through the air, carrying the sound of speakers to our ears. This thing happens due to diffraction. And how does it happen? Diffraction happens when the spreading out of the waves as they pass through around objects. According to the geometrical theory of diffraction, called as GTD, it extends the idea of rays by introducing the concept of diffracted rays that differ from the rays of geometrical optics in that these produced when a ray, in certain cases the diffracted ray itself, hits an edge or a corner of an obstacle. The diffraction is utilized in the design of audio speakers to create a more immersive listening experience. The speaker cabinets are mostly created with rounded edge and curved surface to reduce the diffraction effects. As for the frequency, diffraction becomes stronger at higher frequencies because the wavelength is shorter. This means that the high frequency sounds are more likely to diffract. And when we're listening to music from a speaker, the sound waves it produces spread all into directions. But sometimes, the obstacles like walls can block the direct path of these sound waves to our ears. For example, the edge of the speaker's front panel are designed to be smooth and rounded, which is to minimize the diffraction that helps the sound waves travel smoothly around the edges without getting blocked. And by minimizing the diffraction, the speakers can produce clearer and more accurate sound and enhance the quality of the music. Sound and light waves plays a big role in our world, for example in the building design field. Architects and engineers use sound wave reflection to design buildings, such as conference rooms, and also studios and even theaters. Architects may use absorptive materials into the wall panels or coverings, such as foam, fabric wrap panels, or panels with absorbing sound backing, which is used to prevent them from bouncing back into the room. In the marine field, reflection waves are like echoes underwater. By measuring how long it takes for the signal to return and how strong it is, most scientists can make maps on the ocean floor, find objects on the other floor, or track the movement of the marine animals. It's like using sound to see what's beneath the surface of the water. Now let's take a further look into the medical field. Microscopy is used in biomedical research and material science for imaging the biological tissues, cells at the microscale. The microscopy uses sound waves to visualize the structures and properties of the materials with good resolution or good quality. The diffraction of these waves as they interact with the sample provides information about its internal structure. Moving on to the textile and clothing field, diffraction waves are like effects that can be added to the fabrics. For example, by using lasers or any special printing techniques, designers can create cool patterns and shiny effects on the clothes. Then these patterns can range from simple designs to concrete design. Have you ever wondered why technologies nowadays can develop even faster and faster? It's because the vision leaders can make big changes in how we can understand the sound and light waves. They can inspire people to think in new ways and even try new things, like better ways to use sound or light, and even support research into development of the base technologies. Those are the examples of the application of sound and light waves in our daily life. Hopefully this video will be useful and provides you with good knowledge. Thank you.